So let's look at another scenario. Here we are not given the equation of the lines, but we are given the points that lie on these lines, okay? So as usual, gonna start first by drawing the line that is parallel to the x-axis, okay? And I must make sure that the line passes actually through the not the origin, the point of intersection for the two lines, right? And having done that, we now come to the labeling part. So first of all, I will start by labeling the first angle here. So in this instance, you already know now, I'm going to start off with my angle theta. Oh, by the way, the unknown angle in this case, yeah, this is now the critical part. Very, very important to note. The unknown angle here is this angle. Check this. You have to calculate this angle from here to here. So that's my alpha. Okay, that is what we, so you see it's slightly different from what we had previously, right? Now, I know that using my red line here, I know I have this angle here. And what is that angle? I can call it theta, all right? So let me call that angle theta. And I know I'm going to have another angle, right? Which I usually then again anti-clockwise because we are measuring a positive angle. And this is angle what? Beta. That's usually the big one, right? And then we can write down the relationship. But what is very important in this case is to actually note that alpha is not necessarily the difference, just the difference between beta and theta. It is actually the difference plus something more. Okay, that is the critical part here. In fact, that is the tricky part of this entire discussion. So here the thinking is basically the following. Follow closely now. I am going to recognize that actually there is an angle here. Let me call it Kappa, one of the Greek letters. And I notice that Kappa plus alpha are actually angles on a straight line, and they add up to 180 degrees. That's what I'm going to notice. So remember, I'm going that way. So it's a positive angle. So that's what I'm going to notice. However, I also notice that actually Kappa is also this angle here because they are what? Vertically opposite, right? Grade 8, grade 9 geometry, right? So now, having noticed that, what I can therefore do is to establish a relationship between Kappa, theta, and beta. What you see now is that beta, the red one here, can actually be represented as the sum of Kappa and theta. So we can see the second equation that we are going to have here is that Kappa plus theta, right, is actually the angle beta. That's what we have there. Now, we can use these two equations to find out algebraically what actually should be the angle alpha. In fact, we're gonna do it both ways. So make sure you don't get lost somewhere here, right? We're gonna do it both ways. Now, let's find angle beta. Angle beta, definitely we can see that it is going to be well, maybe let's start with theta because it is quite simple and straightforward. So I'm gonna start with theta here. Maybe I should use the color of theta. So I know that tan theta is equal to m. Now I've got to find the gradient of this line, guys. So you can see, let's quickly find it. M for PQ is actually changing y over changing x. So I'm going to have 2, right, plus 2, and then over 2 minus 3. And so this gradient is actually a minus 4. That's what I have. Now I'm going to quickly find the gradient for RS, and that is also going to be changing y over changing x. So that's going to be 1 plus 1, which is 2, and then over minus 4. And we can see it is actually minus a half when we simplify that fraction. So first of all, for PQ, I'm going to start with tan theta equals to m. So that means tan theta is actually a negative 4. So I've got to find the angle there. Of course, then theta is 104.04, right? Remember, in this case, because we've got an obtuse case, okay, that's the important part, you are going to add 180 to the angle that you are going to find, okay? So maybe let me just do you that favor here and say, well, in this case, theta is going to be the arctan of minus 4 plus 180, because you are still getting used to this. So in this case, it will be 104.04. Now, before we come to the relations, let's of course also now find the angle that is now for the line RS, and we have shown already how that is going to work. So we're going to have again here tan beta now, right, is equal to, what is the gradient here? The gradient is minus a half. So we know that beta will be arctan of minus a half plus 180, because we are having what? An obtuse case. So once again, you can just go ahead and press that in your calculator. I'm doing the same in my calculator here. And then if I add 180, I am getting 153.43 degrees. Okay, I've rounded that. Now, the next thing that will happen then, we have the 2 critical angles that we needed. The next thing that's going to happen is, let's find kappa. Or if we don't find kappa, let's see if we can solve this algebraically. That's it. That's all that is needed. Okay, so let's see, excuse me, how that can go. So I'll start doing this algebraically. You can see I cleaned up a little bit here, but I've written down the angles that we had calculated. And I'm using elimination between these 2 equations, equation 1 here and 2, and that's where I got this result. So let me quickly show you what happens. If I say equation 2 minus 1, then I'm having kappa plus alpha equals to 180. That's my equation 2. And I want to subtract, basic subtraction, guys, column subtraction if you may like, but it is known as elimination, guys, from simultaneous equations that you did in grade 10. Okay, so kappa subtracts kappa, I'm left with nothing here. Now, alpha minus theta is just alpha minus theta. 180 minus beta is just 180 minus beta. That's how elimination works. So that's how I got here. Now, I'm looking for alpha. Do I know theta? Yes. Do I know beta? Yes. So therefore, alpha is 180 minus beta plus theta, which is 180 minus 153.43 plus 104.04 degrees. And this, of course, will wrap up to 130.61 degrees. That's one way to look at it, which is very simple. Another way to look at it, I will not entertain this. It's just for your indulgence and exploration. You could do this. You could find kappa, and I hope you can see from this equation that kappa, let me write it here, kappa is beta minus theta. Then once you have found kappa here, which will give you something like 49.39, you can then see that these are angles on the straight line. Then you use this equation and you realize that alpha is actually 180 minus kappa. Then you just substitute and you will see you find the same answer. So it's really up to you as to which way you want to use. So I've put the two methods to the table. You choose. Cheers.